Picture this. You're sitting in the exam hall staring down a super complex data table for the cardiac cycle. You write down what you think is an absolutely flawless textbook perfect answer. But then results day rolls around and you've completely missed the top mark band. Ouch. So what actually went wrong? Well, in this explainer on the Cambridge Biology 9700 cardiac cycle, we're going to bypass the basic textbook definitions for just a second. We really need to expose the tiny, seemingly insignificant mistake you're probably making right now before we even look at a diagram of the heart.
Because here's a crazy statistic. Did you know that topic 8.3, the cardiac cycle, can account for up to 15% of the total marks in your Cambridge Biology 9700 paper 2? Yeah, 15%. That is a massive chunk of your final grade, wrapped up in just one specific syllabus area. So the stakes? They're incredibly high, and it demands absolute precision from you.
So we have to ask the big, high-stakes question. What tiny mistake is actually costing you these marks? You might think, oh, I just forgot a long biological term. But looking at the principal examiner reports, that's not it at all. The fatal flaw isn't a lack of basic knowledge. It's a lack of analytical depth. Students are basically bleeding marks because they rely entirely on rote memorization. They memorize the textbook, but they have no idea how to translate that into the specific, data-driven reasoning that Cambridge examiners actually award points for.
Section 1. Mastering the cardiac cycle. Why standard revision fails. To really master this, we have to completely abandon standard revision tactics. Seriously, rereading your notes over and over again? It's going to fail. Why? Because this exam doesn't just test your memory. It tests your ability to interpret complex data, crunch statistics, and build logical, causal relationships in completely unfamiliar contexts.
Now, to grab those higher-order marks, we definitely need to establish a quick baseline: systole and diastole. Basically, systole is the active, rhythmic contraction of the heart muscle, literally squeezing blood out of a chamber. Diastole, on the other hand, is the relaxation phase, where the heart chambers open up and refill. Seems simple enough on the surface, right? But remember, examiners don't just want you to recite these definitions. They want you to apply them dynamically to a whole sequence of physiological events.
And this brilliantly illustrates exactly what I mean. Let's walk through it step by step, because it's all about a chain reaction. During atrial systole, the atria contract, which causes a slight pressure increase. Because of this specific pressure change, the AV valves stay open, while the semilunar or SL valves are closed. But watch what happens in ventricular systole. The ventricles contract, resulting in a sharp, massive spike in pressure. This intense physical pressure literally forces the AV valves closed so blood doesn't flow backward, and it pushes those SL valves wide open. Finally, in diastole, the heart just relaxes, pressure drops across the board, and the valves reset. It's this continuous, beautiful loop where muscle action dictates pressure, and pressure strictly dictates the valve status.
Now, what's really fascinating is the direct feedback we get from Cambridge themselves. The principal examiner reports explicitly say this: answers on 8.3 cardiac cycle are often too vague. Examiners want specific details. Now, stick with me, because in just a second, I'm going to reveal the exact examiner clue that fixes this vagueness forever. It's a real game changer. But if you try to use that clue without the right structural framework, it's just not going to work. You need the foundation first to make that clue blindingly obvious. To build that rock-solid foundation, let's break down the top 3 reasons students lose points. First, as we just saw, answers lack specific details. You're describing things instead of analyzing them. Second, and this one hurts, candidates constantly forget to check units and terminology. Writing something like the pressure goes up instead of the pressure increases in kilopascals is a literal exam killer. And third, answers aren't specific to the provided context. If they give you a graph of a mammalian heart rate, you can't just drop a generic textbook answer. You absolutely have to reference that specific data. Section 2, the high mark framework, method mark strategy. So how do we systematically avoid these traps? Well, we use this. This is the ultimate framework designed to capture every single available method mark. In Cambridge Biology, you are heavily rewarded for your process of reasoning. By systemizing how you process the data, you essentially bulletproof your grade boundary. Here is your new 4-step methodology: deconstruct, solve, and evaluate. Step 1 is concept. Identify the core biological principle, like, say, ventricular systole. Step 2 is evidence. Pull the specific data right out of the provided tables or graphs. Step 3 is scientific reasoning. Logically link that raw data back to the biological concept to prove causality. And Step 4, examiner wording. Format your conclusion using strict Cambridge-style terminology. So that's concept, evidence, reasoning, wording.
Memorize that sequence, it's absolutely crucial. And hey, I have to pause here to issue a massive examiner alert. Show you're working. When you're interpreting relationships or calculating stats in Topic 8.3, systematic processing is everything. Listen, even if your final calculated answer is completely wrong, explicitly writing out your framework and showing your step-by-step analysis will earn you method marks. And honestly, those method marks are very often the difference between a B and an A.
Section 3, the interactive challenge. Fix the flawed answer. All right, time to put this into practice. We're going to actively apply that 4-step framework to a Cambridge-style past paper problem. I want you to literally step into the shoes of the examiner right now.
Take a look at this flawed student answer. The pressure goes up, so the valve opens and blood moves. This is exactly the kind of vague, descriptive phrasing that those examiner reports were warning us about. So, pause for a second. Predict how you would correct this using our 4-step framework. What terminology is missing here? Where are the specific units or the named biological structures? Just think about it.
Okay, ready? This comparison brilliantly shows the difference. Look at this top band answer. Ventricular systole increases pressure above aortic pressure, forcing the semilunar valve open to eject blood. Do you see that dramatic upgrade? We applied the concept, ventricular systole. We used scientific reasoning based on evidence, pressure increases specifically above aortic pressure, and we nailed the examiner wording, forcing the semilunar valve open to eject blood. Using this framework takes your answer from a weak descriptive level straight up to a highly analytical top band tier.
Section 4. Higher order assessment. Statistical evidence. Let's escalate things a bit. If you're gunning for those top-tier grades, demonstrating conceptual understanding through words is really only half the battle. Higher order assessment in Cambridge demands that you evaluate alternatives and draw justified conclusions based on hard statistical evidence. When you're staring at raw cardiac data, you have to know exactly which statistical test to deploy. You'll need the t-test for comparing means between two groups, like resting heart rate versus active heart rate. You'll use chi-squared for analyzing categorical data. And you'll rely on correlation tests to spot relationships between continuous variables. Extracting this data, running the correct stat, and drawing an evidence-based conclusion, that is the ultimate flex of mastery.
Section 5. Your next mandatory step. Okay, we've unpacked a ton of high-yield strategy in this explainer. The main takeaways are super clear. Stop relying on vague memorization. You've got to be incredibly specific with your terminology, ruthlessly apply that 4-step method mark framework, and always, always show you're working. But before we wrap up, I need to point you toward your next mandatory step. Because here's a pretty chilling reality. What if you do everything right? What if you apply the 4 steps perfectly? You calculate the stats flawlessly, and you completely understand systole and diastole, but your underlying phrasing is still trapping you in a lower mark band. You have the structural framework now, sure, but there is a hidden cause that could totally ruin your exam score if you leave it unchecked.
That hidden cause? Command words. These are basically the secret gatekeepers of the entire Cambridge syllabus. Think about it. If an examiner tells you to explain the data and you merely describe it, you'll lose over half the marks, no matter how perfect your biological knowledge is. Learning to decode these command words isn't just optional. It is the absolute foundation for figuring out what the examiner actually wants from you.
Which means you absolutely cannot stop here. To seamlessly continue your training and master these secret gatekeepers in our Command Words Masterclass, here is exactly what you need to do next. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Do that right now so I can see you in our next explainer. Until then, ask yourself this. Are you truly analyzing your data? Or are you just memorizing a textbook?